So folks, the required practical in C7, you'll find it in 7.1 of your textbook, is, I just thought I'd get a little bit of extra explanation to help you work out what's going on here. We will do this when you come back to school. So when we're investigating temperature changes, we're actually investigating energy changes. So the way we do that is to look at changes in temperature. So if the temperature goes up, so let's say at the start of reaction it was roughly room temperature, it was about 20 degrees centigrade, and then we add things together, they react, and then the maximum temperature reached by the end of the reaction is 25 degrees centigrade. Then we've gone up 5 degrees centigrade, and that would be classed as an exothermic reaction because heat energy has been transferred from the reaction mixture to the surroundings. If we start the reaction at 20 degrees centigrade and by the end it's only 17 degrees centigrade, then we've actually gone down 3 degrees centigrade, and we would say the reaction was endothermic. Heat energy has been taken from the surroundings into the reaction mixture. So when we do this as a practical, if we just did the experiment in a beaker, for example, beakers are made of glass, there would be quite a lot of energy loss that we wouldn't end up measuring with the thermometer. So the way around this is to use a polystyrene cup. And polystyrene cups are very good heat insulators. So we don't lose a lot of heat using a polystyrene cup. In fact, usually, because that would tip over when we put the thermometer in, what we do is we put the polystyrene beaker in a glass beaker. So we have the glass beaker around the outside, and we have a polystyrene beaker inside, and we put our whatever, there can be various things we could be reacting together for this. So let's say this is reactant 1 and this is reactant 2, and we react them together and they mix, and we would get a temperature change, and we'd know that because we'd have a thermometer in there. Now you're expected to be able to plan an experiment like this, and you're expected to know the reasons for all the things. So obviously the reason for the polystyrene cup is to prevent heat loss, to make your results more accurate. Also, you'd get a lot of heat escaping out the beaker, so actually it's always good practice to use a lid as well, and you can just have a hole in the plastic lid for the thermometer. And the glass beaker is to stop it all tipping over. So key things, you must take the temperature before you react things together, and then you have to take it again after it's reacted. And what you're actually measuring in the experiment is the change in temperature. And a positive temperature would be exothermic, and if the temperature goes down, a negative temperature change, it would be endothermic. Now, a few other key things about that. This reaction can be done with a range of different chemicals. For example, we might give you some different metal powders and get you to do a displacement reaction with copper sulfate. We might do it with different concentrations of acid and neutralise it with sodium hydroxide. So you could be given this question, this practical, in different contexts as long as there was an energy change. Variables wise, the independent variable, which is, as you know, the one that you change. If it was different metal powders and copper sulfate solution, the independent variable would be different metals. The dependent variable in this experiment, the one that you measure to get your results, will always be the change in temperature. Not just the temperature, the change in temperature. And the control variables, the ones that you keep the same, they would be things like using the same mass of metal powder, if we're using metal powder, the same concentration and volume of copper sulfate. Remember, we try not to use that word amount, as that doesn't always get the mark at GCSE, so we try to be specific. I hope that helps. I'm going to put another video link on there for you as well to look at.